In this question, a scientist makes a buffer solution that contains both hydrofluoric acid HF and fluoride ions F-. So we can see in our before solution image, we've got 2 HF molecules and 2 F- molecules. So we can fill that in our table here. We've got 2 HF and 2 F-. To start with, we don't have any OH- and we don't have any H3O+. We just have water, HF, and F- shown on our diagram. Then we're told a small amount of hydroxide ions, OH- are added. And the image is showing we're adding 1 hydroxide ion in our representation here. Well, now we need to figure out what's happening after this has been added. So first let's have a look. I don't see any hydroxide ions in our after representation. So even though we added a hydroxide ion, it must have reacted with something because we're not seeing it in our after image. We also don't see any H3O+. Let's look at our HF. We just have 1 HF here. So we've got 1 HF. And then for F-, we've got 1, 2, 3 F- here. So let's try to figure out what happened. Looking at our numbers here, one of our HFs must have turned into an F-. So let's look at our image over here. This one started as HF and it ended as F-. So that must have reacted, which the OH- added. So you must have had HF plus OH- goes to give us F-. What else happened? So if we're getting an F-, that means we still have an H and an OH left. Those actually combine together to form H2O. So if we count how many H2Os we had before and after, before we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H2O. And after we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 H2O. So when we added the OH-, it reacted with the HF to form F- and H2O. So what happens with the OH- that's added to the solution? It reacted with HF to form F- and H2O. Our next question asks, how are concentrations of OH- and H3O+ compare before and after the OH- is added? Now looking here, we can see we had 0 moles of each to start with and 0 moles at the end. So the concentrations of OH- and H3O+ are unchanged. Both of them remain constant. It then asks us, how does the pH of the solution compare before and after the OH- is added? If we had an increase in hydroxide ions, that would be making our solution more basic, which would be increasing our pH. If we ended up having more hydronium ions or hydrogen plus ions, that would be increasing the acidity of our solution, making it more acidic. But in this case, the concentration of OH- and H3O+ remains constant. So the pH is not going to change. How does the pH change? It remains constant. So this is the idea of a buffer solution. In this one, we have an acid and its conjugate base both present in our solution. So when we added some OH- ions, some base, it reacted with our acid to form the conjugate base again. So instead of changing the pH of our solution, it just reacts with what we already have there to convert between the acid and the conjugate base and produce water. Let's try one more example of this type. In this question, we again have a buffer solution made of hydrofluoric acid and fluoride ions, but this time we're going to add a small amount of hydronium ions, H3O+. So shown here, we're adding 1 mole of H3O+ ions in our representation. I just want to remind you that H3O plus is what we get when we have H plus reacting with water. So usually we talk about acids releasing an H plus ion. That ion actually then goes on to react with water to become H3O plus. So when we're talking about pH being the concentration of H plus ions, we're really talking about the concentration of H3O plus ions. So you can use H plus and H3O plus interchangeably when you're talking about these things. Let's go ahead and count up what we have before. So before we have an HF here, and we have an HF here. So 2HF, and we have an F minus here and another F minus there, so 2F minus. So let's go ahead and fill that in. 2HF and 2F minus before. We don't have any OH minus ions or H3O plus ions before, so those will both be 0. Next we have our after diagram. Here we have an HF, and another HF, so 3 HF after. And we also have an F minus here. So 1 F minus after. And I can't see any OH minus or H3O plus again, so those are both still 0. So this time, we started off with 2 HF and 2 F minus. One of the F minus must have been converted into HF. So this time we had F minus, which in our image would be this one here, getting converted into HF. So F minus reacted with H3O plus to form HF and an H2O. So if we count our H2Os, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 H2O before, and then after we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 H2O after. So we ended up with an extra H2O because our F minus reacted with the H3O plus ion, forming HF and H2O. So what happens to the H3O plus that is added to the solution? It reacts with the F minus to form HF and H2O. We're asked again how the concentrations of OH minus and H3O plus in the solution compare before and after we add a little bit of H3O plus. We can see they're both 0. They remain the same. So both of them remain constant. And lastly, how does the pH change? Again, pH is dependent on our H3O plus, or in other words, H plus, and our OH minus concentrations. If we increase the concentration of OH minus, we'd get a more basic solution, in other words, a higher pH. If we increase the concentration of H3O plus, we get a more acidic solution, in other words, lower pH. But in this question, we've neither increased nor decreased those. They're both staying at 0. So how does a pH solution compare? It's going to be the same, remaining constant, before and after. So in this example, we again had an acid and its conjugate base, and we added a little bit of acid, H3O plus ions. That reacted with the conjugate base to reform the acid. So again, this is the idea of a buffer solution. We have an acid and its conjugate base, and no matter whether we add base or acid, OH minus ions or H3O plus ions, they're going to react with either the acid or the conjugate base to form the other one and water, and they're not actually going to change the pH of the solution. We have the same thing when we have, instead of an acid and its conjugate base, we can have a base and its conjugate acid. Again, they'll react with any added hydronium or hydroxide ions so that the pH doesn't change.